So this one's the part B to the first one. So here is a factor of safety problem, which factor of safety is the ultimate over the allowable stress. And we know that stress is equal to the force over an area, and the force we're looking for is FAD. So FAD over area AD, and we know that area AD is going to be equal to, this is going to be FAD over pi times R AD squared, and we know it's going to be RAD because we're saying these are rods, and this is the cross-sectional area. Cross-sectional area of a rod is a circle, and this is the area of a circle. So from here, let's see, what do we have to find out? So we have this this here. This is going to be FAD with a load of 48 kilonewtons on the end here, and we have this angle theta, and let's see, it's going to be 6. So I guess 6, and then down is going to be 1.5. So we can say that theta is equal to the tan inverse of opposite 1.5 over 6, which is going to be 14.036. And using the sum of the forces in the y direction, we can say that FAD sine of 14.036 is equal to 48. Or would it be like, yeah, I'd say equal to, right? Equal to 48 kilonewtons. Realistically, this shows a down force, and that's a down force, so it should be plus, so it should equal negative 48. I'm just going to write that equals negative 48. So we know that FAD is going to be equal to 48 over sine of 14.036. We know that FAD is equal to 197.91. Okay, wonderful. Now they say that the factor of safety is 3, and the ultimate stress is going to be 120 kilonewtons. We know the stress formula is 120 kilonewtons over pi times 10 squared. We know this because the diameter is 20 and the radius of 20 would be 10. So area here would be pi times 10 squared. And then we have here 197 over pi times r squared. So we can solve for what number this is here. And then we can just call this quantity the allowable. Right? We'll just call it the allowable. So this is going to equals that. So now what is 120 over the pi times 10 squared? And I should say that's 120 times 10 to the third. So this is equal to 381.97. So we see that 3 equals 381.97 over the stress allowable. This means that stress allowable is going to equal 381 divided by 3, which is equal to 127.323. So now we can plug this in here. Because this is equal to this, this is going to be equal to 197.91 divided by pi times r squared. So let's multiply pi r squared by both sides. And then let's divide both sides by pi 127.3. So now we have r squared is going to be equal to 197.91 over 127.323 pi. Take the square root of both sides, and now this becomes r equals this, which is going to be, let's see, second square root alpha y equals 197 over 127.323 pi. Yes, whoops. I plugged FAD in. These are flipped. Sorry about that. This actually should be the square root of, let's flip them. Strike that, reverse it. U allowable is going to be FAD is 197. This is going to be, yes. U allowable. Nope. It should actually all be good. 137. I'm getting 127. It's the same thing as last time. This should be 197.91 times 10 to the third, and this should be 127.323 times 10 to the negative, or times 10 to the sixth pi. This should give you finally the right one. Oh my gosh, why do I always forget that? Times 10 to the third, times 10 to the sixth pi. Okay, now I'm getting that r equals 0.022, and if we multiply that by 2, the diameter is going to be equal to 0.044 meters, so meters to millimeters, this would be 44.4. Check it.